Good morning, boys and girls. We are going to sort of tie up the end of our chapter on graphing and data and probability. Okay, so in the beginning of the chapter, we talked about the different types of graphs: pictographs, line graphs, line plots, bar graphs, and circle graphs. And we said that certain ones were more useful in different situations. Some you could use in any situation, but some lent themselves better to other situations. Okay? Then we talked about probability, where the likelihood, what are the chances that something's going to happen? What are the chances that if I have a bag full of marbles and there are red marbles, green marbles, and blue marbles, what are the chances that I'm going to pull out a green marble? Okay? What are the chances I'm going to pull out a purple marble when there are no purple marbles in there? Now we're going to combine what we learned about graphing and probability together. Now you can use the information from probability experiments and graph that information so that it's easier to interpret. For example, let's say that we had a class of third graders who were going to flip a coin a bunch of times. Okay, they're going to flip a coin 25 times. And we're going to, when we flip our coin, it can either land on this side, which is heads, or this side, which is tails. Those are the only two possibilities. It's not going to land like this. It has to either land like this, heads, or this, tails. Now, just because this heads has a head on it, don't misunderstand that this has to have a tail on it. It doesn't. It's just an expression we use to mean the back of something that we call heads the front and tails the back. This actually has a picture of the United States Capitol building on the back of this nickel. Okay, so if this coin was going to get flipped 25 times, and it could either land on heads or it could land on tails. So we made a tally chart. And the tally chart listed the two possible outcomes. It could land on tails, it could land on heads. That's all we have because we don't have a three-sided coin. And when we flipped it 25 times, this was how it worked out. So basically, we just threw it heads and made a tally mark. Oops, I just dropped the coin on the floor, but it landed on tails. Okay, and we made a tally mark for tails. We did that 25 times. And this is the way it worked out. It worked out so that there were 5, 10, 11, 12, 13 times it landed on tail. And heads it landed 5, 10, 11, 12 times. So about half, 50-50, right? About half the times it was tails and about half the time it was heads. And if you kept flipping this over and over and over again, hundreds of times, you would get results that were like this, where it was almost half equal. Okay, we can't, if you have an odd number, it can't actually be equal because there's, it won't divide evenly. So anyway, this was the results. So we had 5, 10, 13 times it landed on tails, and 12 times it landed on heads. Well, now we can use this information from our tally chart and we can make a bar graph. So the first thing we do is we give our bar graph a title. Experiment, because that's what all these flippings were. They were an experiment to see if it landed on heads or tails. Okay, that's our title. So now we have to figure out what information is going to go up and down on the up and down axis, what information is going to go on the side to side axis. I think it's probably better for us to put it on the y-axis, the sides, because there's only two of them, two choices, two possible outcomes. So we'll draw our bars going this way. So on the side here, we're going to write possible. No, actually, we'll write sides of coin, because that's what's on this side of the information, the sides of the coin. And on the bottom here, we're going to put the number of outcomes, like how it actually worked out. Number of outcomes. Okay, that's what the information is. So the first thing we'll do is we'll put tails on our graph. Then I'm going to skip a line and I'm going to put heads on a graph. These are our possible outcomes. These are the only things that can happen. It can either land on tails or it can land on heads. That's the only choices. So now I'm going to make my scale. Now because we have a 13 and a 12, we have to go out at least to 13. But remember, I told you I always like to go out a little bit further than the end number so that the person who's reading our graph really knows that it didn't get cut off, that this is all of the information because they didn't go off the edge of the page. There's still more room after their bar is drawn. So now we're going to draw a bar graph from this. So let's start here with 0. And then because we have to go all the way out to 13, or 14 really, I don't really want to draw each of those numbers on this chart because it's going to get very crowded and it'll make it more difficult to read. And remember, the whole purpose of doing a graph, of creating a bar graph, is so that you can look at the information quickly and interpret it quickly. If it's too tricky to interpret because you've got everything squished in there, then there's no point in actually doing the graph. So let's make our scale not 1-to-1. Not every line is going to be one number. Let's do, since we're going to 14 and we got 12 and they're both even, let's do each line increment of 2. So this is 2, 4, 6, 8, 10, 12, 14. We could, since we have more room, we could put even more numbers since we have the room. But do you see how these 2-digit numbers are already starting to get kind of close to each other? And if we had put in all those odd numbers as well, it would have been just too difficult to read. So now we're going to use the information from our tally chart. 13. So we have to find 13 on our scale. Well, there is no 13, but we know that 13 is in the middle of 12 and 14. So we pick a spot in the middle and we go up to where tails would be, and we're going to put the end of our bar there. I put a line going up and down like this so I know where to stop. Now I can just go over towards my word tails, and then I shade in my bar to make it easier to read. Now, it doesn't have to be fancy colors. It could just be in solid color like this in pencil. Now I'm going to draw a bar for my heads. Now, heads is 12, and we got lucky. It lands right on the 12. So you find the 12, you follow it up to where the word heads is, and you make your end of your bar. Then you're going to finish off drawing the bar going across. Now, when you draw yours, you're going to have 2 hands. I'm using my phone to record this, so mine's a little sloppier than yours, but you're going to do it nice and neatly with perfectly straight lines because you're going to have 2. Now, 2 hands. So you can see that the 12 doesn't go out as far as the 13. And now you can answer all kinds of questions about this very easily. Now, I always shade it in because in this case, it's not so bad because there's only 2 outcomes. But what if there were 6 outcomes? Then you can't tell what's a space and what's a bar if none of them are shaded in. So I always shade my bars in so we know which ones are bars and which ones are spaces. Okay, so that's one way that we can use our results, our outcomes from a probability experiment to create a bar graph. Well, we can also make a line plot. So let's say I had 6 cards and I wrote the numbers 1, 2, 3 on the card and 1, 2, 3 on a card. I only used the numbers 1, 2, and 3. And then I told my students to, without looking, I'm going to put these cards in a box or a bag. You're not going to look. You're just going to reach in and you're going to pull out 2 cards. And then we're going to add the cards together and see what their sum is. And then we're going to record the sum of each of those different turns of people picking 2 cards out at a time and we're going to put tally marks and make a tally chart. Well, the first thing we have to do is we have to figure out, well, what are our possible outcomes? What are the possible sums that we could even get? Well, can we get a 0? No, because none of the cards have 0. So we can't get 0 as a possibility. 1 cannot be a possibility because even if I took the 2 cards that had the lowest numbers, I still wouldn't get 1. So 2, if you add the 2 cards with the smallest numbers and they happen to be the 2 that I picked out, then 1 plus 1 equals 2 is a possibility. I could pull out a 1 and a 2, right? A 1 and a 2 would give me a possibility of a sum of 3. I could pick out a 1 and a 3, and that would give me the possibility of getting a 4 as a sum. Now notice I'm trying to do this very organized so that I don't forget any possibilities or repeat any possibilities. Okay, so I have a 1 and a 1 and a 1 and a 2 and a 1 and a 3. What if I picked a 2 as my first card and a 1 as my second card? Well, I got that one already. What if I picked a 2 and a 2? If I picked a 2 and a 2, I'm going to get a 4. So I already have that possibility of a sum, 4. What if I picked a 2 and a 3? Well, then I would have a possibility of a sum of 5. That's a different one. Well, what if my first card was a 3 and a 1? Well, I already have 3 and 1. That's 4. What if I picked a 3 and a 2? I already have it up here. So I could pick a 3 and a 3, and that would give me 6. And that's really all my possibilities. I have a possibility of getting 2 as a sum, 3 as a sum, 4 as a sum, 5 as a sum, 6 as a sum. So we're going to add those values now into our tally chart. I'm going to name my one column sum, all these answers here. And then I'm going to put tallies for every time one of my students picks out 2 cards and gets a 2 or a 3 or a 4 or a 5 or a 6. So let's put that in there. 2, 3, 4, 5, or 6. Those are my possibilities. I could get 2 as an answer, 3 as an answer, 4 as an answer, 5 as an answer, or 6 as an answer. Okay, well, let's say that this is the way it worked. That 2 people, when they did it, they got a sum that equaled 2. And 4 people, when they picked cards, they got a sum of 4. And 1, 2, 3, 4, 5 people, when they added their cards together, those 5 different turns, they got 4. And 4 people, when they added their cards together, got a 5. And 1 person, when they added their cards together, got a 6. So this is what my tally chart looks like. 2 people got a 2. 3 people got a 4. 4 people got a 3. 5 people got 4 as their sum, 4 people got 5 as their sum, and 1 person got 6 as the sum. So total, how many people actually picked cards? Well, let's count them. We've got 2 and 4 is 6, plus 5 is 11, plus 4 is 15, and 1 is 16. So 16 people were in my class. I guess somebody was absent that day. And this is how it worked out. Okay, now we can use the information in this tally chart and we could make a bar graph if we wanted, but we just did that. So what if we make a line plot? So remember how line plots go. They start out as a number line. We put arrows at both ends because lines go on forever and ever. And remember, I'm doing it towards the bottom of the page because all my information is going to go above the line. Okay? So I have to leave space to put those X's. That's what a line plot is. That's every time we put a number on our number line, everybody who got that number as their sum, we put an X for each person. So if 2 people got a 2, then over the 2 we would put 2 X's. But now we have to figure out, well, where do I start my number line? Now, in this case, we have a very small amount of information. So we could actually include all the counting numbers between 0 and 6. It would not be a problem because it's not that many numbers. So let's do that. Let's start with 0 and 1 and 2 and 3 and 4 and 5 and 6. We could even put 7 and maybe even 8, so that we've got 2 spots before our first number and 2 spots after our last number. This way, everybody who looks at our graph is going to know none of this graph got cut off. So we go back to our tally chart, and 2 people, when they added their cards, got a sum of 2. So I go over the 2 and I put an X and an X. And 1, 2, 3, 4 people got a sum of 3. So I go over the 3 and I put 1, 2, 3, 4. Now, because my pad has lines, I can make sure that my X's are about the same size. It's a little harder if you're using plain white paper, but if you're using notebook paper, look how easy it becomes to make sure your X's are about the same size. Because otherwise your graph could be deceiving. If you do like these X's this big, but then you make teeny tiny X's next to it, they could either look like the same amount, or the one with more X's could actually look smaller. So if you try to keep your X's the same size, it'll give a better picture of what's going on in your graph. So 5 people got 4 as their sum. So I go to my 4 and I do 1, 2, 3, 4, and 5. 4 people got 5 as their sum. So I go 1, 2, 3, 4. And 1 person got a 6. Nobody got a 0 or a 1. Nobody got a 7 or an 8. Okay, because they weren't really even possibilities. Okay, they weren't even possibilities. Only 2, 3, 4, 5, and 6 were possibilities. Well, now we can do all kinds of things. We could figure out which one you can compare, which one got the most. We know that 4 had the sum of 4 randomly occurred the most. If I asked you which 2 were the same, you could tell me the sum of 3 and the sum of 5 came out the same amount of times. Okay, you can do all kinds of information using your line plot. So now this was 2 examples of using an experiment, either picking a card from a box without looking or flipping a coin, recording your outcomes in a tally chart, and then using the tally charts to either make a bar graph to show the information or a line plot.